Okay, so today we're going to just do a few problems from our homework set that just to help you maybe get past. The first one I've got to start with is number 14 on 4.3. Ours looks like this, and so what we want to do with the first thing, I would suggest getting everything as, instead of having a radical, make it to a certain power. Okay, so the first step is I would suggest is going ln of x to the fifth times, and then I'll put in parentheses x squared plus 4, and then it's going to be to the 1/2 power. I should ask you that, but anytime we have a radical, remember this is assumed a 2 when there's not a number there, and then it's always the denominator of the fraction. So then I still have then x plus 4 to the 7th power. Now what I'm going to do is I'm going to go ahead and not worry about the powers, but anywhere it's multiplied, tell me what, when we do the logs and we separate them out, it will actually, the property says we're going to do what with them. Similar to this, remember when we started, if we have x squared times x to the third, we know that that's x to what power? The 5th, because you added those two together. So it's actually 2 plus 3. And remember, logarithms have the same properties because they're exponents. So wherever I multiply, that means I'm going to separate them out and we're going to add them. So I'm going to start off with the ln of x to the 5th plus the ln of x squared plus 4, and put that in parentheses, all to the 1/2 power. Now if I'm dividing, what do we need to do? So again, it came from the property, if I have x to the 5th power divided by x to the 3rd power, we know that this is going to combine, when we simplify, it's x to the 2nd power, but it's also, the way you can write it is x minus, or 5 minus 3. So anything that's divided, we're going to also then subtract. So this part is divided, so we're going to go minus the ln of x plus 4 to the 7th power. So the last step is going to be the power rule. When we have a power to a power, what you can do, we will do is multiply. So the 5 is actually going to come out in front, and it comes again back to the idea that if I have x to the 2nd power all to the 3rd power, then I know that that's actually going to be 2 times 3. But in this case, I'm going to pull it out in front. I'm multiplying it times that logarithm. So the first one in my rule is going to be 5 times the ln of x. Now, what will be the second one?
X squared plus 4 to the 1.
Yeah, but pull the 1/2 out first.
Oh, yeah, okay.
So
1/2.
ln. Now, and then the same thing, last one, minus, pull out the 7, pull it out in front. 7 ln of x plus 4. Now, when you're adding it, this is one term, and so is the x plus 4, and so you will not separate those out. I can't do anything more with those. So in other words, that's going to be my answer written in then the log as the log expanded form in logarithm. So plot that one in. Okay, so then the second one we're going to do is problem number 22 on 4.3, and I've kind of got it written out, and I went uphill for some reason. I'm not really sure why, but we'll just go ahead and deal with it. So remember, we're going to do the opposite of what we just did. So wherever we see the plus, we know that we're going to multiply the logs inside. And first of all, before we did, I kind of just assume now, we have the same logs. Okay, this one is considered log base 10. So if there was any other that would be log base 5, then you can't combine them. But all of them are the same. So then we're going to go with log. Okay, and then I'm going to start with, if I have a plus, I'm going to multiply these together. So I'm going to go the x times x squared minus 49. Now I see that I'm going to divide by 4 and divide by x minus 7. So that means that has to be on the bottom part of the fraction. So I'm going to go log of 4 and then I'm going to have times x plus 7. Now, you can still operate, like I could distribute it in. I'm really not going to get anywhere with that because I'm looking at it at x to the third minus 49x. You can still simplify. I noticed that on this one I have x squared minus 49. I also have an x plus 7 on the bottom. That means I could factor this out. So I could change then the x squared minus 49 to x plus 7 times x minus 7. Okay, and that would indicate that I could then cancel one of my factors of x plus 7. So I could change this to the log of x times x minus 7 all over 4. Remember that you still can't have x to equal a negative 7, but that would also be, I think, did you try the first one? What did you input?
For what?
For this problem, did you input it? Or let me see if I can. I'm going to go back and just type it in. So I'm going to go log of, and then I'm going to go a fraction. So I'm going to go ahead and go x times x minus 7. Dennis Tedrick. Okay, I'll get that in a second. But I had 9, so I'm going to go 9 times, or over 9. Oops. And then check.
Yes.
Okay. It might also work if you put it in the factor form. I don't know if they might have said it was the correct answer, but it just needs to be factored.
Okay.
So that kind of gives us a couple of problems on that one. If we go down to even some of the harder ones, okay, you're going to graph. Let's do one that you're going to graph real quick.
26.
Yeah, let's do number 26. So then I'm going to go ahead and share.
Mine is 6, or log base 6, x plus 2.
Okay, so log base 6. Remember, we talked about it before. It's the inverse of the exponential functions. But in this case, we'll always have the point when. What I want to do is I want to start by doing the parent function real quick. And that's just going to be the log base 6 of x. And so what I'll do is I'm going to lightly pencil that one in. And I think you do the same thing on your computer, and then you actually tell it to shift. Am I correct on this one?
Yeah,
I think that's the way you'll input. We're going to actually find it. I guess you're going to start off by finding it. But here, let me do the quickly. So on this one, if I go log of base 6 of x, when x is equal to 1, so in other words, if I think about it in terms of a t-table, x and y, and I also go when x is equal to 1, I'm going to have the log base 6 of 1. And that's, again, 6 to the 0 power is going to be 1, so this is going to be then 0. So I have this point. Then I'm going to also, when x is equal to 6, and the reason I pick 6 is because my base is 6. I could go ahead and go 2, and I could go ahead and put it in my calculator, but it's not going to be a whole number. So this means if I have log base 6 of 6, that's 6 to what power is equal to 6, so that means that it's going to be the value of y is going to be 1. So when I'm going to go over 1, 2, 3, 4, 5, 6, I'm going to have the point 1. And if I go 1/6, so that's another, again, I'm keeping my same base. If I have log base 6 of 1 over 6, then that means it's going to be 6 to what power is 1/6, which would be then a negative 1. So I know that when it gets really close, it's going to be down here at negative 1. Now, I'm going to kind of just lightly pencil that one in because that's not what you're looking for, because you have a shift. So my original function then, I'm going to take all of these points and I'm going to shift them what direction? Close. You're right. If you had, let me just do it, that would be log base 6 of x and then it would be plus 2. This one would be up 2. Okay, that's a good, I'm glad you brought that one up. But since the 2 is within my logarithm, it's going to go left 2. And think about it in terms of what I want. I'm still going to have an asymptote right here at when x is equal to 0. So I can't, I'm just going to move everything. My asymptote then is going to be shifted 1, 2. So it's going to go left 2. My point here when x is equal to, when it was, this is really 1, 0. Now it's going to be left going back 2. So I'm going to go 1, 2. It's negative 1. And then it's going to, my graph is actually going to look the same as that one. Remember, this was the point 6, 1. So that means this point now is going to be 4, 1. So then when you go back to your graph, look for the one where you have an asymptote of minus 2. And in this case, mine, did you find yours? Mm-hmm. I'm going to go ahead and put mine, mine is minus 1. So okay, I'm going to check my answer. Let me see if I can go to the minus 1. Mine's a little different than yours.
I think it's A.
Oh yeah, because mine is minus 1 and yours was plus 2. Yes, good job. Okay, then did you have other questions with that one?
No.
No, okay. Well, I thought there might have been a follow-up,
Yeah,
and so that's what I was going to just check. So, but anyway, just then you'll go. So that one makes sense then? Okay, so kind of think in terms of your parent functions, and then also you might have some that are shifts up and down. All right. Does that make sense so far?